Alright, this is part 2 of the circles this week. So mainly you want to be able to write an equation of a circle from a graph, and then because there's a little repetition that I noticed here, so I added a little bit of a challenge. So because you guys are too smart, so got to be challenged a little bit. So I want to see if you guys can write an equation of a circle by completing the square. So that'll be cool, because you'll do more of that in Algebra 2 as well. It's used for different things like solving quadratics, etc. So it's a nice skill to have. All right. So first, let's try to write an equation of this circle. First, you have to kind of identify the center and the radius. So can you tell the center? You have to find a spot where it's the same distance out to the, the outside of the circle. So let's just, it looks like it's really centered right at the center, right at the origin. So let's test it out. So it looks like we go 1, 2, 3, 4 in that direction. Looks like 4 in every direction. So this would be the center. So center would be 0, 0. Okay. So let's say center 0, 0. Okay, the radius, you can tell, you're counting 4 units out to the outside of the circle each time. So let's say the radius then is 4. All right, so then we just do the same as we were doing before. We just can write the equation of the circle. So we would go x minus, in this case, I guess we would say x minus 0 squared plus y minus 0 squared, and then equals the radius, which would be 4 squared. And we don't typically say x minus 0 squared, as we saw in the last, video. So we would say x squared plus y squared, and that would equal 16. So that would be a little cleaner, simplified version. All right, next one. All right, let's try to find out where the center would be. It looks like it'd be about right here. Let's make sure. So let's count the number of units. So we go up, and don't be tricked, check your scale. It looks like we just go up 2 units, and we go over 2 units, down 2 units. So it looks like 2 units in every direction. So we would say first, let's identify the center. So the center would be, let's say -4, 0, and the radius would be, again, counting 2 in each direction, so the radius would be 2. Now we're able to write the equation. So we're going to say x minus, and now remember how this x minus, it would be x minus a -4. So if you want, you can just change that to x plus 4 squared plus, and then it would be y minus 0 squared equals, and the radius is 2, so that would be 2 squared. So I would simplify that a little bit. So that would be x plus 4 squared plus y squared, and I shouldn't even put that in parentheses. So y squared, and then equals 4. So this would be a little cleaner version. Now, if you like actually plugging in the -4 in there, so that you do x minus a -4, you should do that. So if that helps you, see that x minus a -4, that's how that becomes x plus 4, please do that. I just don't usually do that, but that's just a preference. All right, next, let's find a good center here. All right, this one's a little goofier to find the center. I'm gonna guess it looks like sort of like right here, but I need to verify that. So I'm gonna go in each direction. So I'm gonna go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 down. Okay, so that looks like that's the center. So the center would be -1. That would be -1, 1. And the radius would be 5. All right, so then we write the equation. We would do x minus a negative 1, so then I would make that x plus 1 squared plus, and then y minus whatever the y coordinate is, so that's a 1 squared, and then it's going to be the radius squared. And again, some of you guys are just really going to skip that step. You're just going to say, oh, it's 25, and that's totally cool too. All right, let's make sure I didn't mess anything up there. All right, looks good. Circle that. That's your circle equation. All right, now this is sort of repetitive because I think we did this last time, but I just saw it on the homework a little bit. So state the center. So the center is pretty easy for us, right? Working backwards. So this has a plus 10, so that must mean the h part of the center there is going to be negative 10. And then this is already set up as y minus, so that means we just leave it as a 7. So negative 10, 7. And then the radius is, remember, just the square root of this number. So that would be 6. So square root of 36, which would be 6. All right. Same for this one. So we're going to say the center would be, see how that's already set up as x minus, just like that equation. So that means the h is going to be just a 14. This one is supposed to be set up as y minus, so that means this would be a negative 8 as the y coordinate, if you will, of the center. And then the radius is going to be the square root of this number here. So that's going to be 4, because the square root of 16 is equal to 4. That's where we're getting the radius each time. All right, so that was too easy for y'all, so we got to teach you a little bit of completing the square, so you could do these harder ones. All right, so how can you complete the square? And I'll show you why that is in a second. Sometimes you'll have an equation of a circle or equation of a other type of conic section, like a parabola or an ellipse, that is not in a beautiful form, but you'd really like to write it in a really nice standard form so you could easily figure out, what the center and the radius is. Because isn't it easy to figure out the center and the radius when it's in this form? So that's why we would like to put it into that form. So let's say we have one that's kind of in this form, and they say, hey, can you figure out the center and the radius? Well, I really can't. When I look at that form, I don't even know what the center and the radius is. So I have to put it into a really nice looking form before I can tell. So I want it to look like this, the normal equation of a circle formula, standard form. So there's a really nice process to do that. So first I need to review, what is completing the square? What is that? So you might have done this in Algebra 1-2. You really should have done it in Algebra 1-2. It's a way to make a trinomial turn into a perfect square trinomial. And so you have to add this perfect number to it. So in the little technique, just to remind you how to do it, is you look at this middle term, this linear term is what it's really called, and you look at the coefficient. So whatever the coefficient is, that's the number that's in front of the x. Whatever that is, you just divide it by 2, and then you square it, and that becomes the magic number that you add. So you divide it by 2, and then you square it. So let's take 6, and we'll divide 6 by 2. So 6 divided by 2, that equals 3, right? And then we're going to square that. So the magic number is 9. So that means that x squared plus 6x, we would add a magic 9. Now what is so great about a 9 being added to this trinomial? Well, what it does is it makes a perfect square trinomial so that this thing factors amazingly. So this thing factors as x plus, and you just take the square root of this, and you take the square root of this. So it would be x plus quantity squared. And this is equal to the same thing, So you could, if you wanted to check it, you could do x plus 3 times x plus 3, multiply it out, with the distributive property or FOIL if you learned it that way. You multiply it out, and it would equal the same exact thing. So the fact that we can factor it really nicely, that's what makes this a perfect square trinomial. That's completing the square, okay? All right, let's go back to our problem, see how we could do one of these big guys. So what you do is you complete the square possibly twice. So in this case, twice. So we would do x squared plus, and what you do is you group the x's together and you leave yourself a nice little blank, and then you make sure and group your y's together. So y squared minus 12y, and then you leave yourself a nice little blank. And then the constants, these are called constants when they're numbers that don't have variables, just regular numbers that don't have variables. The constants always get moved over to the right-hand side of the equation. So it's 48, and then I would leave myself a couple of blanks, okay? Because I'm going to add a special number here to complete the square. So I'm going to figure out what is the magic number that I would put in this blank. Well, I would take half of 8, so half of 8 is 4, and then I would square it. So that means this would be 16. So again, half of 8, so it would be 8 divided by 2, and then I would square it. Okay, so 8 divided by 2, that's 4. 4 squared, 16. That's your magic number. All right, what about for 12? Well, you don't even have to worry about whether it's a negative or a positive because you're going to be squaring it anyways. And you know when you square negative numbers, they turn out to be positive. So just take half of 12, so that would be 6. 6 squared, that's 36. So you know this is an equation, so it has to be in perfect balance. So if you add 16 to the left, you got to add 16 to the right. And if you add 36 to the left, you got to add 36 to the right. The equation is in perfect balance still. Now, what's cool about this is that it creates a perfect square trinomial right there, and it creates a perfect square trinomial right there. So this one would be x plus, and it's whatever the square root of this is, so that's 4. And again, you're not having to like reinvent the wheel here. I mean, it was 4 before we squared it. And then we got y, this is a minus because that's a minus, so y minus, and then square root of 36, so that's 6 squared. And then we have to add those together. So I'll just make sure I don't make a mistake. I'll use my calculator. 48 plus 16 plus 36. That is 100. Beautiful. All right, that is the equation of a circle right there. And then isn't it easy to figure out the center from that? So now the center would be the opposite, you know, because it's always set up as x minus. So then the center would be negative 4. And then this one is y minus, so that would just be 6. And then the radius would be equal to, should be 10. So radius equals 10, or however you want to write that. So 10 it is for sure. All right. So now if you understood how to do that, I have the 3 challenge problems for you. So you would, pause the video and give yourself, a good amount of time to tackle each of these problems. Sound good? And that way, you're sort of ending the year with a nice challenge and something that, you'll utilize for next year as well. Definitely need to be able to complete the square when you're solving harder quadratic equations and or trying to put conic sections into, their proper, function, whatever it is, whether it's a parabola, like I said, or an ellipse or a circle, okay, or a hyperbola, I almost forgot. All right, let's see. So once you have written these down, then you can scroll to the next couple of slides. I just worked them out already, so you can just kind of check the work and everything, but I definitely think you should give these a shot. You can definitely do it. Okay, there's the solution to the first one. Okay, again, don't peek at these until you've tried them yourself. All right, and then here's the second one. Yeah, see that? And then here's the third one. All right, and you notice I'm sliding the y squareds over to the left-hand side, and I move the constant over to the right-hand side before I got going on adding these magic numbers. All right, that ought to do it. Here's the Waldo Social Distancing Edition. I found him. Oh my gosh, I'm so good at this. All right, have a great week.